Alright, this is section 6.1 and we're talking about exponential functions. So for any real number x, an exponential function is a function of the form f of x is equal to a times b and b is raised to x. So a is going to be a non-zero real number called the initial value. B is any positive real number such that b is not equal to 1. Okay, so positive real number. The domain of f is all real numbers. The range of f is all positive real numbers if a is greater than 0. And the range of f is all negative real numbers if a is less than 0. The y-intercept is 0, a, and the horizontal asymptote is y equals 0. Okay, now these two, they may change depending on the transformations, which we'll get into next time. Which of the following equations are not exponential functions? Okay, so 4 raised to 3x minus 2. So what we have to check is we have an x value in the exponential place, and this number right here is not negative, so that is an exponential function. Here I do not have an exponential, well, I have an exponential, it's 3, but I do not have x in the exponent. So this one is not an exponential function. Okay, we do have an x in the for the exponent, and 1/3 is positive, so that one's good. Okay, we have the x as an exponent, and -2, well, that's a negative, so this cannot be an exponential function. Okay, so the only two that were not was this one right here and this one right here, because it says that b, the thing raised to x, has got to be a positive real number. Okay, let's look at evaluating exponential functions. So recall that the base of the exponential function must be a positive real number other than 1. That's talking about b for base. Why do we limit the b or base b to positive values? So to ensure the outputs will be real numbers is why we do it. So let's take a look at if it wasn't a positive number. Say let's let b be equal to -9 and x be 1/2. Okay, so we would plug in -9 for b and 1/2 for our exponent. And remember, 1/2 is the same thing as the square root. So we have the square root of -9. Now remember, when we have an even square and a negative inside, that's not going to be a real number. We're going to have to pull an I out. So this would actually be I square root of 9, and so that would be 3i because square root of 9 is 3. Now 3i, that's an imaginary number, so that's not a real number. Okay, so that's why we have to limit it to b being positive values, and that's why it can't be negative values. Why do we limit the base to positive values other than 1? Okay, well, because base b results in a constant function. So let's look at this. If it is 1, so we're going to raise 1 to x. So for any x value that we plug in there, 1 raised to -1, 1 raised to 0, 1 raised to 5,000, it's still going to be 1 no matter what x value that you put into it. So that would be a constant function instead of an exponential function. So it changes it. It changes what the function is. So that's why we have to have b being a positive number, and we have to have b being something other than 1. So to evaluate an exponential function of the form f of x equals b raised to x, all we have to do is substitute x with the given value and calculate the resulting power. So for example, if we have f of x is 2 raised to x, then what is f of 3? Well, I'm going to change x and substitute 3. And then I have, so I'm right here. Then I have 2 raised to 3, so 2 times 2 times 2. This is 4 times 2, and this is 8. So my answer would be 8. So the function evaluated at 3 is equal to 8. Okay, so let's look at this one. So we're going to find f of 2. So 5 times 3 raised to 2 plus 1. So 5 times 3 raised to 3. Okay, 3 times 3 is 9. 9 times 3 is 27. And then 5 times 27 is 135. So that would be my final answer. So let's look at this one. F of negative 1, so negative 4 raised to 2 times negative 1 plus 3. So negative 4, negative 2 plus 3. So negative 4, and that's 1, so this is going to be negative 4. Now notice I have a negative outside of the 4, and that's okay as long as I don't have something like this to where, say this is what they gave me instead. Now this would be an issue because b would be a negative, and some of our values would not be real numbers. They would be imaginary numbers. But when the negative is on the outside, or that you don't have parentheses around that 4 with that negative included inside, that's okay. So that negative 4, this function right here, or this function right here, that's okay with a negative on the outside. It's just when you have parentheses and the negative on the inside, like this right here, is where you're going to have issues. Because we could write this as this right here. We could write this as this function right here, where that negative 1 is actually our a. And it says that a is a non-zero real number right here. Okay, well, it just means it can't be 0. Otherwise, this entire thing would be 0. And so looking at this problem here, a is not 0, it's a negative 1, so that's fine. But our b is a positive number, that's not 1. Okay, so that's the difference between those two. All right, let's look at this one right here. So f of 1, negative 2, e raised to 1 minus 1, so negative 2, e raised to 0, anything raised to 0 is 1, so this is negative 2 times 1, so this is negative 2. And that'll be our final answer. And we're going to talk about e just a little bit later. E is actually equal to, or approximated by 2.7188282. So we know that e is not a negative number and it's not 1, so it's okay to use as the base here. Now let's look at this one right here. F of 3, so negative 3 over 2, 3 raised to negative 3. So negative 3 over 2. Now when I have a exponent that has a negative, that means you need to flip what is inside the parentheses here. So that will change it from a negative to a positive. So 1/3, and now this is a positive 3. Okay, so 1/3 times 1/3 times 1/3. 1 times 1 times 1 is 1. 3 times 3 times 3 is 27. So I have negative 3 over 2 times 1 over 27. I can take a 3 out here and a 3 out here, so that'd be left with 9. Okay, so then I have a 1 times 1, and keep that negative, and then a 2 times 9, so 18. So negative 1 over 18 would be my final answer there. Whoops, I forgot to add that little piece right there. So that wouldn't be my final answer. So I need plus 3 over 2 here, plus 3 over 2, plus 3 over 2. Okay. All right, so equal to, we said that's negative 1 over 18, and then plus 3 over 2. Okay, I got to get the denominators the same, so I'll multiply this 9 over 9. That's a form of 1, so I'm not changing anything. Okay, so that will be 27 over 18. So negative 1 plus 27 over 18, so that's 26 over 18. Then we can take a 2 out of both of those, so that would be a 13 over 9, and that should be my final answer there. Okay, so this one is 3 over 2, so 16 raised to negative 3 over 2. Okay, so I have a negative again, so I'm going to flip the inside to make that exponent positive. Now notice this right here is the root. This right here is the power. So I have the squared root of 16, and then that whole thing raised to 3. Okay, so here's my root 2, and here's my power 3. Okay, so we need to find the square root of 16 first, and that is 4. And then 4 raised to 3, or 4 times itself 3 times, would be 64, and that would be my final answer. Okay, now this number e. The letter e represents an irrational number, and it has this formula to it, 1 plus 1 over n raised to n, as n increases without bound. That just means it keeps going on and on and on. Don't necessarily have to remember this right here. The letter e is used as a base for many real-world exponential models, so it's very common to run into it. To work with base e, we use the approximation e is about 2.7188282, and that's really all we need to know about e at this point. Okay, so calculate e raised to negative 3. Round your answer to 2 decimal places. So I'm going to need a calculator for this part. Okay, so let me get mine up. Here it is. So we're going to, there's e, and then I hit x raised to y. I put open parentheses, 3, make that negative, close out my parentheses, and then I hit enter. Okay, so I get 0.0497, I think there was an 8 over there. Yes. Okay, yeah. So what we need is 2 decimal places. So 1, 2, okay, that's a 9, so that's going to increase my 4 to 5, so my final answer is 0.05. Then let's look at this one right here. Okay, let me bring that calculator back up, clear it out. So now I have e and raised to 8.12. Okay, 3361.0207. 2 decimal places. Hey, that's a 0, doesn't change anything. So 3,361.02 would be my final answer for that one.